All right, hello everyone. So just to kind of remind or to sum up what we did in the last video, we're really looking to see if there's evidence that SLU students answered this question correctly more often than they would just by randomly picking A, B, or C, or maybe less often than just randomly guessing, or if there's not evidence for either of those things. And so what we're going to do now is set up a couple of competing hypotheses. And so our null hypothesis is often going to represent a claim to be tested. And so usually it's represented by either equality. So there will be some sort of equal sign in our null hypothesis, or no association. And so we'll get to this one when we talk about doing hypothesis tests for more than one variable that we're interested in. And so for our example, we're going to think about our null hypothesis. And so to abbreviate it, we're going to write H0. So that's our notation for the null hypothesis. And then we're just going to think about, all right, what would the proportion of correct answers be if people were just randomly guessing? And so we've actually already answered that. We answered that up here. If we were randomly guessing, we'd expect about a third of people to get the question right. And so our null hypothesis is that the proportion, the true population proportion, is just going to be a third, corresponding to random guessing. The alternative hypothesis is going to be a competing claim. And so our definition is just going to be an alternative claim to the null. When we have more than one variable, the alternative will be that there is an association between the two variables that we're interested in. For our example here, it's just going to cover all of the cases that aren't in the null hypothesis. And so we're going to abbreviate it as H with a little a for alternative, give it a colon, and then say that this proportion, the proportion of all students who would answer this question right, is different than a third. And so this is going to be our hypothesis that's corresponding to something other than random guessing. So it could be better than random guessing, could be worse than random guessing. All right, and so these are the hypotheses that we've set up. And when we do a hypothesis test, we're going to evaluate how much evidence there is for these hypotheses. In particular, we're going to evaluate how much evidence there is for this alternative hypothesis. So how much evidence that we're doing something other than random guessing. The tough part will be kind of attaching a number to how much evidence we have. And the number that we'll attach is our p-value. And so the kind of last definition here is just the null value. And so this is just the value we are comparing the parameter to in the null hypothesis. It's just a fancy word for whatever this number is going to be, right? So this isn't always going to be a third. Like if there were 4 choices here, then our null hypothesis corresponding to random guessing would be p equals a fourth. If there were just 2 choices, it'd be p equals a half. And so our null value is just whatever number is in this null hypothesis. We're going to denote that as p with a little 0. since the 0 was also in that null hypothesis, and this is often pronounced P naught. Okay. So we're actually going to skip over the rest of this page. We will come back to it, so don't throw it away or anything. Skip over all of page 4. Again, we will come back to that as well. And then skip over most of page 5, though we will come back to that also. We're going to jump straight into the components of what the hypothesis test actually is. And so in the next video, we'll resume at the bottom of page 5 when we define a p-value and then go through an example to see how that p-value is calculated.